Okay, let's talk about relations and functions. Owen, what do you know about a function?
Not much.
Not much? All right, tell me the little bit you do know that.
I don't remember. I don't know.
Oh, so you lied to me.
Yeah.
Just like the Eagles when they said they were going to be good this year, and they
Yeah.
stink. It was a lie. All right, that's okay. We're going to learn all about it today. So a relation, okay, and I know everything's written out here, but a relation is just like a pairing of numbers, okay? Just two things you kind of put together. That's a relation. So what is a function? Well, a function is when you put something in, you get something very specific out. Meaning for each input, there's an output. So up here, okay, a relation is a set of ordered pairs. The set of the first component in the ordered pair is the domain of the relation. And the second component is the range. And Marcus, you're like, what? What does that mean? First component, second component. Yeah, it's very simple. Ready? Every function or relation has two parts. Are you ready for this? X and Y. That was easy, right?
Yeah.
So they have two parts, X and Y. It's alphabetical. The X comes first, the Y comes second. So that first number in an order pair is your X. The second number is your Y. That's what the first component and second component means. All right? Now, I will interchange terms. So you need to know what those terms are. Okay? Domain, X value, and input all mean the same thing. Got it? So if I say domain, and I say what's your input, I'm talking about the same thing. I'm not changing things up. Those are all the same. Likewise, Y, range, and output are all the same thing. They all mean your Y values. Got it? So just because I'm saying like, oh, what's your domain, what's your input, what's your X value, doesn't mean I'm changing or trying to trick you. It's all the same. That's what you guys have to know, because I don't want you saying like, oh, we're in the middle of SATs. I don't know what domain is. I interchanged. Got it? We cool with that? Now, find the domain and range of a relation. Well, that's easy. Watch this. Domain is this. Domain is all of your X values, which are all of these first terms here. So ready? Your domain is 0, 1, 2, 3, and 0. That's it. Nice and easy. Meaning your range are all of these second terms. So that's 1, 3, 5, 5, 3. Now, I like to repeat it just so that I have the same number of domain and range. Okay, I like to do it that way. Some teachers might just put, oh, your domain is 0, 1, 2, 3, and your range is 1, 3, and 5. Got that? But I like it this way. It all matches up, makes me feel nice and warm. Okay. I like that feeling. Okay, when things balance out. All right, now today is going to be more about functions. So what is a function? Well, it's very simple. Garrett,
Alright.
you ever been to the vending machine here at Pencrest High School?
Yeah.
You have. Good. Good. What's your favorite thing to get out of the vending machine?
Those little like Gatorades, like tiny Gatorades.
I was really hoping you were going to say the pirate booty. Always found that weird that we have that in there. Pirate booty. It's just weird. All right, Gatorade. Garrett's favorite thing to get is Gatorade. Now, why am I asking about vending machines and stuff like that? Garrett, have you ever typed something into a vending machine and gotten something you didn't want?
Not no.
Not here?
Yeah, I don't think so. I don't.
Ah, that's because it's a function. Okay? Now, how the heck is a vending machine a function? Well, a vending machine is a function because you put your money in, and then it's got letters and numbers. Okay? And to get your Gatorade, it might be like C8. So you'd hit the C and you'd hit the 8 and you get your Gatorade. All right? Or for me, the Pirate Booty, that's like A12. You put in your dollar, you hit A and 12, you get out your Pirate Booty. Now, that's a function because if it wasn't, if I put in A12 for my Pirate Booty and I got out Garrett's Gatorade, I would not be a happy camper, would I? Could you imagine if you went to a vending machine and you plugged in, you're like, yo, I really want that Snickers. And you put in like $2 or $1.75 and you typed in C13 and you got out like a Milky Way, you would be sour. You would not be happy. Or would it, Marcus, what if you got the pretzels?
That's game over.
You're breaking the machine. Okay? Unless they're the sourdough. They're pretty good. All right? But if you get those like pretzel sticks, it's like, well, I just wasted $2.
Basically, it's just dry mouth.
Yep. So that's why it's a function. You put one thing in, you get one thing out. Function. Okay? Now, that's what it is in like kind of real life terms. In math terms, it's quite simply for every x value, there's exactly one y value. Meaning, if I put something in, it's not like I'm going to get two different things out. So as long as I put one thing in and I get one thing out, I'm happy. I'm unhappy when I put one thing out and it goes to 2 or 3 or 4 different places. That's not a function. Okay? So that's the formal definition. I'm not reading it. What I am going to read is this. And Miss I, I'm going to need your help here because I'm going to try and use different stuff. Question number 1. The input value x is any of the 50 states in the United States. And the output value y is the number of governors of the state. Okay? So, Marcus, I'm going to give you an easy one. I'm going to give Miss I the hard one. Okay? Ready?
Yeah.
Marcus, I pick Pennsylvania. Who's the governor of Pennsylvania?
Tom Wolf.
Tom Wolf. Very good. There's only one of them, right? There's not more than one Tom Wolf?
No, I don't think so.
Okay, good. All right, so we pick Pennsylvania, and I get one governor out, right? It's nice. It's easy, right? You ready? You test your knowledge. New Jersey.
Well, it's Murphy.
Murphy. Very good. Very good. So, I put in New Jersey and I got Murphy out. One governor, right? Now, is that a function, Kitchen? Is that a function? Yeah, you're right. It is a function because if I put one state in, I get one governor out. Well, what would it be like if it wasn't a function? Well, if I put in Pennsylvania and I got Murphy, okay, or Tom Wolf, that wouldn't be now I have more than one governor. And that's not how it works. So A is a function. Now, you have to use your brain for that. And sometimes it's a little tough. Sometimes, 8th period, you don't like using your brain. You're just like, just show me what I got to do. Let me do it. Let me log off. So let's look at B. But to do B, Miss Gregg,
Yes.
do you see how I'm underlining all of the x values?
Yes.
That's the only thing I care about. Do any of these x values repeat?
No.
No. Function. As long as the x values do not repeat, I got a function. That's the nice, easy way about this. So now what does it look like when something is not a function? I have two functions. One of these got to be not a function. Miss Simpkins. Miss Simpkins,
Yeah.
I want you to look at C.
Okay.
What do you notice about the inputs of C?
It goes
There,
up by twos.
there's what? There's two what numbers?
No, I said for the first, like, it goes from -1 to -3, so it goes up by 2.
Oh, no, just look at the input, just the first column,
Okay.
okay? So that first column, what do you notice about those numbers? -1, 3, 4, and 3.
3 is twice.
3 is twice. Guess what? Because of this, not a function. As long as that x value doesn't repeat, we got a function. Now I have to pick on Rachel. There's 3 people in. Come on, like, you knew I was calling on you. You can't say no. You're in class. That's how it works. Rachel, this is a mapping, meaning it's kind of like a picture drawing of like a table, okay? You see that? I need to figure out which one of these columns is the input and which one's the output. Is A the input or is B the input? I'm sorry, I can't hear you. Sorry? A, very good. A is the input. Why is A the input? Well, notice the things are going from A to B. Do you see that? From A to B. So A is the input. Now, Rachel, this is the easy one. Ready? Ready for this? Do you see how in A goes to 1 and A goes to 2? That's the equivalent of saying 3 goes to 2 and 3 goes to 4. Not a function. It's not a function because you have one input, namely A here, that's going to 2 different things. Okay? That's like going to the vending machine and putting in A12, and you either get the strawberry milk or you get the Gatorade. One of which is going to be good before track, the other one's not. Can you imagine getting the strawberry milk before you had to go run like a 5K? Game over there. Game over, Mr. Kinsley. Game over, Mr. Kinsley. All right. Let's look at the bottom. Kelsey.
Yep,
Awesome. How are you? How was your weekend?
it was good. How was yours?
It was pretty good up until the Eagles lost, and then I realized I had to pay Owen in push-ups. Some man, my word. So I'm hoping he's out tomorrow. But so Kelsey, let's talk about these functions. Now we don't have a table. We don't have like a mapping. I don't even have a sentence. I just have this equation. So Kelsey, we're looking at A, B, and C. Which one of those is a function?
I don't know.
Take a guess.
A.
A. A is a function. A is a function because notice y is by itself. Okay? Y is by itself, and that's not the only thing that makes it a function. Okay? But it's y equals like an x value, right? There's nothing funky going on there. If we type it into our calculator, which if you guys have, do you have it? Oh, type it in. If you type it in to y equals x squared plus 1, okay, you're going to get this shape. It's a U. It's a u. It's like kind of you took the u and moved it up like 1 unit. Okay? Now, here's how you tell if it's a function. It's easy. Ready? Take your pencil. Lay it on your screen, vertically, on your screen. All right? Drag it across your screen. Now, you'll notice that your pencil only ever touches your graph at 1 point. It's not going to touch at 2 points. It only touches at 1 point. Okay? You'll see what I mean about that later. But I'm just going to take, ready, kitchen? This is my pencil. Ready? I put it on my screen like this, and I just drag it across. And as long as my pencil touches the graph 1 time, function. Something called the vertical line test. We're going to get into that in the next section, but it's good for today. So because this passes, okay, the vertical line test, this is a function.
Wait, I put it in my calculator and it just said error.
It's because you probably put it in wrong. Did you type in y equals, do you hit that?
Y equals x, the second paragraph.
Yeah, we see what you typed. It's a plus sign.
The plus sign?
Did you go to the nurse and get your eyes checked out?
I actually think I need glasses.
Oh.
No, I know I need glasses, but I just didn't get it. It still says quit. Error.
Because you're typing in like the letter X and not the variable X. All right, now let's pick Abby. Abby, B or C? One of them's a function, one of them's not a function. Which one's the function? What do we got, Abby?
Is B the function?
B is actually not the function. It's C. And I'm going to show you why, Abby. And I make mistakes all the time. So don't be ashamed about it. You learn more from making a mistake than you do from actually getting it right. Ready, Abby? I'm going to show you why B is not a function. Are you with me here?
Yep.
All right, ready? Here we go. Let me rearrange B into a nicer format. So I'm just going to get y by itself. So I'm going to add y squared to both sides. And that's going to give me x equals y squared plus 2. Still with me?
Yeah.
Subtract 2. So that's going to give me y squared equals x minus 2. And here's what's going on, Abby. Let me make a table. I have an x and y table, right? And I'm going to pick a very specific kind of value for x. I'm going to take 6. So Abby, what is 6 minus 2?
4.
4. So what number squared gives me 4?
2.
2. Is there another number?
No.
No other number that I could square and get 4. What if I told you it was -2, Abby?
Okay.
So Abby, here's the thing with this one. Is when you do stuff to the y, that's going to make it kind of like not a function. That's like a telltale sign. Like, bro, nobody jacks with the y. You don't mess with the y. The y. See how I'm messing with the y in B? See how it's y squared? That's kind of something you haven't seen before. That's kind of be like, yo, something's a little funky about this. Maybe I need to slow down and check it out. That's why, Abby, it's not a function. Because when I pick 6, y could either be 2 or -2. I don't know which one. That's like getting chocolate milk or strawberry milk. Nobody wants chocolate. It's always strawberry. You disagree? You can go in the hall and learn from the hall. It's going on YouTube. All right. Let's continue with this stuff, and I hope I got time to get it done. So write a set of ordered pairs that represents the rule of correspondence. So functions are used all the time. Now, Mr. Kitchen, I know you play football, so I'm going to pick on you for the football one. All right, this is going to be comparing Super Bowl winners and the team that won it, right? So in 2004, it was the Patriots. I believe they beat the Eagles that year. Rough year in my life. Cried a lot. Okay, Dominic McNabb, T.O., broke my heart. Okay, the Patriots won. 2005, the Patriots again. Another rough year. I hate the Patriots. Okay, 2006, the Steelers. At least we're bringing the championship home to PA. I'm okay with that. And then 2007 Colts. What was that? Was that Peyton Manning? So there you go. All of that. That is a function. Despite the fact that the Patriots won 2 years, still a function. Because it's not like you had 2 Super Bowl champions in 1 year. You didn't have like co-champions. It's weird. That's why I don't like when like leagues are like, oh, we can have co-champions. You're like, there's only 1 champion. Not everybody gets a participation medal. And then the square, Abby, this goes back to you. I can do anything to the x. It's going to be like generally all right. Okay, as long as I don't divide by x, okay, I get nice things. Okay, so this is the parabola. This is the x squared. It's just a u, not a function. But let's go on to this new stuff down here called function notation. And I like function notation. Why? Well, we're just going to replace that y button on your calculator with the f of x button. Now, why do I like the f of x button? Because the f of x button pretty much stands for a function of x. Function starts with f. The f of x starts with f. It's nice, okay? And that's all it is. It's just replacing the y button. So when I'm plugging these things in, I'm just going to hit that y button and just plug in the back half here. So if I'm trying to do this, Mr. Kitchen, I'm just typing in 3x minus 4. And then what does this mean? It just means, oh, x is 1. I'll show you. So if you want to type that in now, you can go ahead and start on. So the name of the function is that cursive letter. That's going to be f. So the name of the function is f. The domain is x. And the range is f of x. Okay, that's your output. And it's read f of x, a function of x. So what does this mean? Well, this just means I'm going to take my function g of 1. So I want to know, what is the value of this function when x is 1? Did you type that in, Mr. Kitchen? Okay, you can type it in your calculator, but all I'm doing is this. I'm going to replace the x with 1. So g of 1 is 3 minus 4, which is negative 1. Now, to bring it around full circle, if you go to the table, did you go to the table? Now go to 1, where x is 1. Is y negative 1? So, Mr. Kitchen, all this means is this is equivalent to the point 1, negative 1. Okay? Now, you could use the table to get this one, right? So you could go for B, you could go to where x is negative 2, okay? And then you could see, don't tell me, well, here I'm just going to replace x with negative 2.
So what would we put into our calculator?
You don't. This is like in your head. To do what Kitchen's doing, you take that in, and then this is your x value. So this answer would be x is 1 and y is negative. So here, I'm just going to take x and I'm going to plug negative 2 in for x. Anywhere I see an x, I plug it in as negative 2. And notice I put it in parentheses as well. So that's negative 6 minus 4. So that corresponds to negative 10. So that's the point negative 2, negative 10. Right, Mr. Kitchen? All right, now what does g of y mean? Well, it means I'm just going to replace x with y. So g of y is just 3y minus 4. I didn't do anything. I'm just changing the x to a y. Seems silly, but that leads to bigger and better things like d. Well, what do I do in d? Well, I'm just going to replace the x with x plus 1. Notice when I plug it in parentheses. Exactly what was here is going in there. So there we go. And now what I want to do is I want to simplify. So I get 3x, and then 3 times 1 is 3, minus 4, well, that's negative 1. So g of x plus 1 is 3x minus 1. Well, how do I do e? Well, e is g of x. Well, g of x is, right, it's 3x minus 4, right? That's g of x, plus, what's g of 1? Well, I use red for a reason, right? What was g of 1? Negative 1, right? So this is just saying g of x plus g of 1 is the same thing as saying 3x minus 4 plus negative 1, which is 3x minus 5. Now, I was asked last period, and it was a great question while you guys are filling that out. It was, how do you know what I'm going to want? Am I going to want the point, or am I going to want just like negative 1? So the way you'll know is this. It's the way I write it. If I say evaluate the function, g of x equals 3x minus 1 for g of 1 like this, I'm just going to want that number negative 1. If I say, what is the ordered pair for the function when x equals 1, well, then I'm going to want the ordered pair. I'm going to be very specific. And for this stuff, I'm typically going to let you know, if I want an ordered pair in like Schoology, the assessment thing, it's going to be like parenthesis, blank, comma, blank, parenthesis, right? I'm going to set you up so you know what I want. Okay? If I want just a value, it'll say like g of 1 equals blank, and then you just type in the number. So it was a good question worth knowing. And if I wanted something like e, you would just type in 3x minus 5, no spaces. Okay? Now, what the heck is going on down here? Miss I is like, Harmon, I got you on the governor stuff, but this ain't my thing. I don't know what's going on here. Well, listen, COVID-19 is happening right now, right? And I'm not going to avoid it. I'm going to talk about it. Well, here's how I'm going to talk about it. COVID-19 over the summer was kind of flat, right? It was behaving one way. So in the summer months, now you're throwing calculators. This is why we can't have nice things, Marcus. No, so COVID-19 was behaving one way over the summer. It was kind of flat, right? And then it kind of started taking back off, right? We started getting that curve. So what this is saying is you can have a function that has like different behaviors in different sections. So kind of think of it like, the pandemic right now. It's behaving differently during different times of the year. So we have different models to represent that. In f of x here, okay, it behaves one way when x is less than 0, or in other words, when x is negative, it behaves this way, following x squared plus 1. After that, once it kind of like, I guess, turns positive, it follows this. And that's all I'm saying is just pick and choose where it goes. So this is what I mean. Writing this I, negative 1 would go here because it's less than 0. So I'm going to plug it into that one. So f of negative 1 goes into negative 1 squared plus 1. So f of negative 1 is 2. Easy enough this time? Now for b, well, we're looking at this, Marcus. B goes down here because that's where x is 0, right? X is 0 in this one. So f of 0 goes into that one. So f of 0 is -2. Ready, Owen? -2, well, that one's up there. So f of -2 is going to be equal to -2 squared plus 1. Notice, again, it's in parentheses, right? Look at the number. It's in parentheses. I put it in parentheses. It's in parentheses. I put it in parentheses. The zero is even in parentheses. I put it in. Why am I doing that? Why am I harping on it? Inevitably, you're going to forget the parentheses sometime. -2 squared is -4. -2 in parentheses squared is 4. That's why I'm doing it. Got it? So here, f of -2 is 5. Last but not least, how do I do f of -3? Okay. Well, f of -3, well, if we look at that, well, -3 goes in the top one. So that's going to be equal to -3 squared plus 1. So f of -3 is 10. And then we have f of 4. So that's going to go in the bottom one. That's going to be 4 minus 2. Well, f of 4 is going to be 2. Well, now I have f of -3 and f of 4. I'm going to add those two together, and I get 12. So there we go.